This is lecture example number 2 from Unit 13. And there are 3 parts. So part A gives us, so what we're doing is we're writing the equilibrium expression for 3 different reactions. So it says N2 plus 3 H2 yields 2 NH3s, 2 ammonias. And if we write the equilibrium expression for that, it's products over reactants, and each of the compounds is raised to the power of its coefficient. So in this one, KEQ would equal the concentration of ammonia squared, because that coefficient, divided by the concentration of nitrogen just to the first power times the concentration of hydrogen, and that would be cubed. So that's how you would calculate KEQ for this reaction. The next reaction is, come over here. So this is reaction B, and reaction B is 2 SO2s, and that's a gas, plus O2, which is a gas, yields reversible reaction. I guess I should have done that up there too, otherwise it wouldn't reach an equilibrium. 2 SO3s, also a gas. And when I go to do the equilibrium expression for this reaction, they are all gases, so they can all go in the equilibrium expression. And it's going to look like KEQ equals the concentration of SO3 squared divided by the concentration of SO2, also squared, times the concentration of oxygen gas just to the first power, because there's no coefficient in the balanced equation. And lastly, reaction C is BiCl3 as an aqueous compound plus water as a liquid reacts to form BiOCl as a solid plus HCl as an aqueous compound. So when I go to write the equilibrium expression for this reaction, and that's supposed to be 2 HCl's. Since water here is a liquid, it is not going to be included in the equilibrium expression. Same thing for BiOCl. It's a solid. I can't measure the concentration of a solid. I can't measure the concentration of a liquid, so they are not included in equilibrium expressions. The equilibrium expression for this reaction, KEQ, would equal the concentration of hydrochloric acid squared, because of that coefficient of 2, divided by the concentration of BiCl3, because it's an aqueous compound. And that's how you would do equilibrium expressions.